Problem 15. When the seller decided to sponsor a Halloween party, they set two ticket prices, $10 for advance tickets and $15 for tickets at the door. Letter A says to write a rule for income I as a function of the number of tickets sold in advance, A, and tickets sold at the door, D. So we're supposed to write a rule, and anytime you see something where it has that type of wording, it says I as a function of something else, that means our rule is going to say I equals. What's going to be on the other side of the equal sign is everything that comes after that. In this case, tickets sold in advance and tickets sold at the door. We're going to use the money information from the word problem. Advance tickets are $10, so we'll show that with 10A. And tickets at the door are $15, so we'll show that with 15D. And if we add those two quantities together, it should equal our total income. Letter B, suppose that the event planners have a goal of $1,500 in ticket income and have sold 75 tickets in advance. How many tickets must be sold at the door to reach the income goal? Let's start by writing down the information that they give us. They're giving us a number for I and a number for A. D is what we're supposed to be solving for. And so we'll put those numbers into our rule from part A, replacing I with 1,500 and replacing A with 75. Then our job is to solve for D. We'll multiply 10 and 75 together to get 750. Then subtract 750 from both sides. And the final step to isolate D would be to divide both sides by 15. That gives us an answer of D is equal to 50. And that means that they would have to sell 50 tickets at the door in order to meet their income goal. On part C, it says if the income goal is set at 2,000, write an equation that can be used to answer the question, what are possible combinations of tickets sold in advance and at the door to reach an exact income goal of 2,000? We're going to use the same rule as parts A and B. The ticket prices haven't changed, they're just giving us a different number to put in for I. And so we'll replace the letter I with 2,000. Now we need to sketch a graph. The best way to do that is to find the intercepts. We'll start by finding the x-intercept. And since advance tickets are on the x-axis, the x-intercept is going to be found when they sell 0 door tickets, or when the number of door tickets is equal to 0. So we'll take our rule on part C and plug in 0 for D. That gives us the equation 2,000 equals 10A. And if we divide both sides by 10, then we get a value of 200 for A. That gives us a point that we can put on the x-axis, or in this case on the advanced tickets axis. Next thing that we want to do is find the y-intercept, which means we're looking at the number of door tickets when the number of advanced tickets is 0. And so that means we're going to take our rule and plug in 0 for A. When we simplify that equation, that gives us 2,000 is equal to 15D, and then we would want to divide both sides by D. So that gives us 133.33 for our y-intercept, which doesn't really make any sense. And according to tickets, you can't really buy 0.33 of a ticket, but it still gives us a point that we can plot on the graph. Now that we've got our x-intercept and our y-intercept, we can go ahead and connect those two dots with a line, and that's the graph of our equation. Alright, question E says to use shading to identify all possible solutions to the following question. What are possible combinations of tickets sold in advance and at the door that exceed an income goal of 2,000? There's many different combinations that would fit that situation, and so we use shading on our graph in order to show that. If we're wanting to exceed our income goal, then that means we need to shade in all the points that are above the line.